Hello everyone, welcome to today's class. This is Teacher Simon taking you through Pure Mathematics 3, paper 9709/35 for May-June 2025. And this is part 2 for questions 7 to 11. Question 7, the equation of the curve is y is equal to the arctan of 4x. Then part A, find the exact values of x when the gradient of the curve is a quarter. So this involves what? Differentiation. So if we have our y, which is equal to the arctan of 4x, then I can take the tan this other side, and then I have tan y, which is equal to 4x. Now I'm going to differentiate. This is an implicit equation now, okay? A function of y then is equal to a function in x. So here, I need to differentiate this with respect to x, okay? And also this other side, I differentiate with respect to x, because x is the independent variable. It is the one that changes first, and then you get the y, right? Now, from here, we know that when we differentiate with respect to x, a function of y, this one will be equal to, first get that function of y. You differentiate it with respect to what? To y. Okay, then from there multiply by dy dx, so that when I multiply by dy dx, this dy can cancel, and then I remain with my derivative of the function with respect to what? To x. So when I'm differentiating this one, I will get sec squared y, but I will multiply by dy what? Dx. That is what we call implicit differentiation, and then here we shall get a 4. So what does this one mean? This one means that dy then dx is going to be equal to 4 out of sec squared y. But sec is the same as 1 plus tan. Sec squared is 1 plus tan squared y. And what is our... okay, they said the exact values of x when the gradient is this one here. So we can, from here, I can have 4 out of, okay, the tan of y, we see it here as 4x. So when I substitute here, then I will square it, not so. 1 plus 4x, then squared. And this one will be 4 out of 1 plus 16, x squared. Then I will equate this one to a quarter. Also, that's what they gave us here. And the gradient, you know, is the same as dy dx. So when I cross multiply here, we shall have 16, which is equal to 1 plus 16x squared. Then this will be 15 when I take the one this other side, and it subtracts from the 16. And then this is 16. That then we shall have 15 out of 16, which is equal to x what? Squared. Also, and therefore our x is going to be equal to plus or minus the square root of 15 out of what? 16. And they said find the exact values of x. So those are the ones there. I can maybe write the answer like this, because this 15 here is not a perfect square, so I leave it with the square root. And then when I take the square root of 16, of course, that one gives us a 4. So those are the two x values, the positive and then the negative. Part B, find the exact value of this integral here. When we are integrating y here with respect to x from 0 to 0.25, this one is integrating y is arctan of 4x. And this one here, when we are integrating inverse trigonometrical functions, there are two functions here. There is algebraic and then inverse trigonometric. So there is a one which is silent here, okay? So remember now, if we have two functions, a product of two functions, then we use this acronym here, ILET. And I've always explained what it means, okay? Where this one is inverse trigonometrical functions. Inverse trigonometric functions, okay? Then L here is for logarithmic functions. Then A here is for algebraic, okay, functions. And then this one here is trigonometric. So inverse trigonometric is different from trigonometric functions. So they are treated differently. And then here we have exponential functions. Now, the one that comes before the other is the one you differentiate. So we have I here and then the A, okay? So inverse. Now, inverse comes before the algebraic. That means that is the one to differentiate. The one that comes before the other is the one we differentiate, then the other we integrate. So our u is therefore going to be equal to the arctan of 4x. Now, from here, when you bring it this side, that is tan u, which is equal to 4x. Then we are supposed to get what? Du dx. But from part 1, okay, from part A, we saw that if you have this one here, then the dy dx is equal to 4, okay, 4 out of 1 plus 16x squared. You see that? So I will just deduce here, and I say that du dx, without wasting any time, I will just say du dx is going to be equal to 4, then out of 1 plus 4, it is 16x squared. By the way, another thing you can use here to differentiate this very fast, okay, inverse trigonometrical functions, this is what you do. For if y is equal to inverse of a function, okay, inverse of a function, then dy dx is going to, in fact, not inverse of a function, arctan. Let me just make it clear here. Arctan of a certain function of x, then dy dx is going to be equal to, you are going to get the derivative of that function, and then you divide by 1 plus f of x, then you square this one, like that. This one will help you. Don't you see that what is here is the derivative of this one? And then down here we have 1 plus this one squared inside. So that is that. Then what else do we have? So dv dx is going to be equal to the one here, okay? Remember, one function is supposed to be integrated. That is the dv dx. Then our v is equal to the integral of 1, then dx, which gives us an x. We don't need to put plus c, okay? Because we are going to substitute in the what? In integration by parts formula. So we have the integral. You have the integral of u, then dv dx with respect to x. Then this one is equal to uv, then minus the integral of v, then du dx. You see that? Now, this is the one we are going to use integration by parts. Now, bring this one here. The integral of this one here then shall be equal to, what is our u? Our u is the arctan of 4x. Then what is our v? It is x. Then minus the integral of v, which is x. Then du dx is this one here. So 4 out of 1 plus 16x squared, then dx. Then I can close here. We have 0.25 and then 0. Now, here I can see a 4x in the numerator. Okay, if we have something then plus something of x squared, and here we are just having a what? A constant. When we are integrating, that one gives us an arctan. But if we have x squared down here, and then up here we shall have, like, we have an x, then that means we are going to use the natural logarithms. So I will differentiate the denominator. When you differentiate 1 plus 16x squared, you are going to get 32x. Are we there? Now ask yourself, what are you going to do to this 32 of x to get 4x? We shall divide it by 8, not so? 32x, when you divide it by 8, or you multiply it by 8, you will get the what? The 4x. Now, this operation you have done on the 32 of x is the one you're going to put on the natural log of the denominator. Are we there? So, in other words, here, I can put this one here, up here, with a 1 over 8. You see that? Okay, so that means that what we are having here, let me just duplicate this down here. And then here, I'm going to have this one off. I can have the integral of, now 1 over 8, then times the derivative of 1 plus 16x squared. Then out of this 1 plus 16x squared, this is 0.25, and then 0. You see? Now, after this one here, we shall have x, then the arctan of 4x. It is better to write this one first here so that you don't confuse it with this, okay? Then minus, this will be 1 over 8. This one is the exact derivative of what is down here. That means we are having natural log of the denominator. Okay, natural log of this denominator here. Then we can put our limits, 0.25 and then 0. All right, let's put 0.25. So we shall have 0.25 here. Then the arctan of 4 times 0.25. 0.25 is the same as 1 over 4, not so. So here we shall be having a 1. Then minus 1 over 8. Then the natural log of 1 plus 16 times 0.25 squared. Then after that, subtract. We shall have here is 0. And also minus, even this one will be a 0. Because when you put this one as a 0, then natural log of 1 is also 0. You see that? Okay. So this one here is 0.25 is a quarter. Now here, arctan of 1 will give us 45 degrees, but you write it in radians, pi over 4. Then minus, here is 1 over 4. Then squared, it will be 1 over 16. So times 16. Then that one gives us what? That's a 1. Then 1 plus 1, that's a 2. So meaning we shall have 1 over 8, then natural log of 2 here. Did they say exact value? Yes, exact value. So I'm going to write my answer here as pi out of 16, then minus 1 over 8, then natural log of 2. As simple as that. Question 8 part A. By sketching a suitable pair of graphs, show that this equation here has exactly one root in this interval. Now this equation here cannot be solved using the usual algebraic methods. So that means we are supposed to use numerical methods. So that's why here they are telling us to show that the root lies in between those two. And then the last part then has to be to get the root of that equation. Now we need to get just a few coordinates and then we plot them. Okay, so I'll take my y1 to be equal to 1 over cos 2x, or cosec 2x is 1 over 2x. Okay, then y2 to be this one here, the linear equation, negative 2x, then minus a half. Then I'll draw a table here, and then I get just like 3 coordinates, and then we go. So I have x here, I can have 0, because if this is the interval 0 to 90, then I can have 45 here, and then the 90. Then y1 is equal to 1 over the cosine of 2x, and then y2 is equal to negative 2x minus a half. When I put 0 here, cos of 0 is 1. So here we shall get a 1. Now let's put pi over 4. So pi over 4 times 2, that's a 90. Not so? Cos of 90 is 0. So that means 1 over 0 is undefined. Not so? You know that. 1 over 0 is undefined. So that means here we have undefined. In other words, this x is equal to pi over 4. That line there is an asymptote. The curve doesn't cross it. You get that? Then let's go to 90. 2 times 90, that is 180. Cos of 180 is a negative 1. Then 1 over negative 1, you get a negative 1. Okay? Then how about here? When we put 0 here, of course, we shall get negative 0. What? Then 5. And then pi over 4. And then we also put pi over 2 here. Negative 2 into pi out of 4. Then minus 0.5. This one gives us negative 2.07. How about pi over 2? I'll just come to this one here, and then I put 2. That is negative 3.64. Negative 3.64. Okay, now let me draw the axes here. Then this one, pi over 4, is an asymptote. So I can draw that line there. Just like that, because the curve is not going to pass through it, okay? Then I make it dotted. We always make these asymptotic lines dotted. Okay, then what else? Now let's plot 0, then 1. It has to be here. Then we have pi over 4 is here. Then the y is undefined, so that means it will come like this and then follows this graph like that. It's an asymptote. Then pi over 2 with a negative 1 is here. And of course, since this one is an asymptote, then this one will follow it just like that. Okay? And then let's go to this other one here, 0, negative 0.5, which has to be around here. Then negative 2.07, maybe just below this one here. Then I get my ruler, and then I draw a line through those 2 points. For a straight line, I just need 2 points. Okay? Then we can extend this one just like that, such that it can cross the y and x axes. Now we can see that there is 1 point of intersection here. So because there is 1 point of intersection, then there is exactly 1 root in between. Where those two are going to meet is the root. You see that? Then part B, show by calculation that this root lies between them. So we have these two here. Remember, if you have a graph, this is maybe the x-axis. So if I join these two together and then I put them on one side, we are going to have sec 2x, which is equal to negative a half of, I think it is negative 2 of x, then minus a half. I will bring everything on one side such that we form a function. So this will be 1 over cos 2x, then plus the 2x plus a half, which is equal to what? 0. That means the function in x is the one which is 1 over cos 2x, then plus 2x, then plus a half. Now, when this function here is a 0, that means the value of x we put in this function to give us this as a 0 is what we call the root. Now, suppose maybe the root was coming like that. So the root is here. if the root is there, we can have the x-coordinate on the left of the root and also an x-coordinate on the right of the root. When I substitute x1 here, I will get a y-coordinate which is above the x-axis. I'm just giving an example, okay? So since it is above x-axis, this one is positive. And then when I also substitute this one in here, it will correspond to y value here, which is going to be a negative. You see that? Because it is below x-axis. Now, since these two values of x, they give a different sign, okay, of the function, then that means that the root is in between the two. Don't you see here? For two values, one on the left and one on the right, they should give different signs of that given function. All right. So now let's check in here. We have to put f of 0.8 and then also f of 1.2. So we shall have 1 over cosine of 2 times 0.8, then plus 2 times 0.8, and then we add a half. Same thing here, 1 over, then cosine of 2 times 1.2, then plus 2 times 1.2, then plus a half. Then what do we get here? And then here. Now, if you check here, we can see that there is a trigonometrical term. So therefore, the calculator must be in radians strictly. If you do it in degrees, you'll get wrong things. Mine is already in radians. We have 1 out of cos of 2 times 0.8, then plus, this is 2 into 0.8, and then plus the 0.5. That is negative 32, okay? Negative 32.1471, 32.1471, and the rest of the figures that come forth. Then how about this one here? So where there is 0.8, I will put 1.2. Okay, we have 1.2 here, and then also here we shall change it to 1.2. Then we get our answers 1.54387, 1.54387, and whatever was coming forth. Now, do you see that there is a change in the sign? One is positive, the other one is negative. Okay, so you conclude, you don't just stop there. You say, since there is a sign change, between f of 0.8 and f of 1.2, okay, then the root lies between, you just write this statement, okay, lies between 0.8 and 1.2. Part C, show that if a sequence of real values is given by the iterative formula, this one here converges, then it converges to the root in part A. There are two methods here. You can rearrange this to see that you get what we were having here. Okay, you rearrange to get this one. Or you rearrange this one to get what is given where, what is given here. You see that? Now rearranging to get equation in part A, to get equation in part A. Okay, just drop these ends, okay? You remain with x, then which is equal to a half, then the arc cos of negative 2 out of, for x. It is better to rearrange. That is when you can get the other one straight away. But if you begin from part A here, you're going to get problems. Sometimes it becomes a little bit challenging to manipulate, okay? So always manipulate this one given. If we can cross multiply, this one will be 2x, which is equal to the arc cos of negative 2 out of 4x plus 1. And then take the cosine this side. We shall have cosine of 2x, which is equal to negative 2 out of 4x plus 1. Okay, cross multiply, because remember the other one is sec, which is 1 over cos. So I can switch these ones. This one comes here, this one down here. Okay. Yeah. So what shall we have? 4x then plus 1 then shall be equal to negative 2 out of cos of what? 2x. You see that? Then what else do we have here? I can even bring this one here, and you have 4x here plus 1, then divide by negative 2. Then this will be 1 over cos 2x. Now here 4x divide by negative 2, then you get negative 2x. Then 1 divide by negative 2, you will get negative a half. And then here this is sec 2x, and it is out. We had sec 2x, which is equal to that. Then part D, use this iterative formula to calculate this root correct to 3 decimal places. Give the result of each iteration to 5 decimal places. Now, since we have seen that if you have x1 here, then x2 here, and the root is in between the two, it is better to have the initial approximation as the average of these two, because it draws them near to the root. You get it? But you can use any. You can use the 0.8 or the 1.2. Okay? But me, I always recommend that you do it. You get the average. So let the initial approximation be, let's say, x1, which is going to be the 0.8 plus 1.2, which becomes a 2. When you divide by 2, you get a 1.0. Now, what is x2? I'm going to substitute in here. So it's a half, then the arc cos of a negative 2 into, is it 4x? 4x plus 1. I guess so. It is 4x plus 1. Yes, like that. Then you get the answer here. Remember, calculator in what? In radians. Okay. 1 out of 2, then arc cos of negative 2 out of 4 into, now we are having 1.0 and plus 1. And then we close this big bracket. We are getting 0.99116. 0.99116. Remember, we are putting the answers to 5 decimal places. Then we can go back and substitute. Now, where is this one? I put this one here. You don't need to write this one again to waste time. Okay, just show the examiner this first substitution. The rest, just write the values. Okay, so let's put this one here. We shall come to this one where there is 1.0. We shall put 0.99116. Do not write answer. You just press this answer and then it comes in there. It will fail. Okay, sometimes it fails. So just put the answer you have rounded to these 5 decimal places. So this is 99271. 0.99271. Then the next one, put this one here. 271. That is 99244. 99244. And then the next one here, we shall put 99, then 244. That is 99249. 99249. Now let's see what this one rounds off to 3 decimal places. Here we shall have 0.993. Here 0.992. This one is 0.992. Since these two are the same, then this means these are the minimum number of iterations. Okay, the 5 we are having here. Then we are supposed to do one more. Are we there? We are supposed to do one more, which confirms this one. Because sometimes they can ask you to find the minimum number of iterations you can have. That is when you get 2 values which are giving the same rounded to the given number of decimal places. Okay, Then the next one you do confirms. So let's check this one out here. We are supposed to put 0.99249. We have 99248. 0.99248. Now these three are all giving the same answer, which is 0.992 to 3 decimal places. So this implies that our root is going to be 0.992 to 3 decimal places. As simple as that. Question 9 part A, we are expressing this one in partial fractions. Now, if they give you this part A to express in partial fractions, the next part you expect it to come from binomial expansions or integration, okay? But then, before you do partial fractions here, always look at the degree of the numerator and the degree of the denominator. If the degree of the numerator is greater or equal to that, I mean the degree of the denominator, okay, this fraction is improper, so you have to make it proper. Is equal to that of the denominator, first long divide to get a proper fraction. Okay, so that is that. Now this 12x squared minus 55, actually it is a plus, then minus the 2 here, then out of 3x minus 2, and then here we have x plus 6. This one is the same as 12x squared plus 55 of x, and then minus 2. And then here we are going to divide it. This is 3x times x, that will be 3x squared. And then 3x times 6, that one gives us 18, then minus 2, that will give us a 16 also. A 16, so we have positive 16x, and then this times that, we shall get negative 12. Now the degree, what do I mean by the degree? It is the highest power of x. So this is the highest. You see that? The highest power of that variable in there, or unknown. So that is a 2. Now we have to do long division here. They are the same. Okay? So I'll get, this is my dividend. I put it inside here. And then my divisor is this one here. I'll put it here. So when you are doing long division, the first, you divide the first with the first. Divide this with this one here. And also that as we go on. Then the rest you multiply. I said, divide the first with the first, the rest you multiply. So 12x squared divided by 3x squared, we get a 4. Now I will get this and then I multiply by 4. So we get 12x squared, then 16 times 4. We shall get a 64. And then negative 12 times 4, that will be a negative 48. Then we subtract to do away with this one here. 55 minus 64, that is a negative 9 of x, and then negative 2 minus 48. This one will be a plus, and then we get 40. Isn't that 46? So positive 46. Now the degree of this one is a 1. It is less than this one, so that one becomes the remainder. So this simply implies that what we are having here, okay, is equal to 4, then plus what we have gotten here, okay, here, and then we are dividing by what we are having here, again the denominator. Okay, when you divide 7 by 2, you get 3 whole number, then you get a remainder. So 3.5 is 3, then plus that a half. this is the remainder. So this is our remainder here, then the divisor. So that is that. Now we can reduce this one to partial fractions. What shall we have? We shall have negative 9x then plus 46 out of 3x minus 2, then x plus 6. This one is going to be a out of, these are linear factors, okay? Linear factors, so we split them like that. This times that, and then this times this. Then this will be the denominator, okay? So we shall get a into x plus 6, then plus b into 3x minus 2. Then this one is supposed to be equal to negative 9x plus 46. Why am I equating to that? These ones here, they are going to be divided by this one here. You get that? And since this one is an equivalent fraction, so we are saying that this one is equivalent to this, you see? So this is the common denominator they are having. You see that? So do you see that the numerators have to be equal? So you don't have to waste time. What you have to do is when you reach here, you just multiply this in this, then this in that, then you just equate to the numerator. Then you look for values of x that can terminate one of the terms in here, then you remain with one term. For example, if x is equal to negative 6, this one will go away. Then put negative 6 here, this will be negative 18. Negative 18 minus 2 is that negative 20, so that is negative 20 of b, then which is equal to, put negative 6 here, that will be positive 54. Positive 54 then plus 46, that one gives us 100. Now that means when we divide all through by negative 20, then b becomes, what is going to be our b? B is going to be negative what? 5. As simple as that. Then what makes this one a 0? Just get this one and equate it to 0, right? Then your x here is going to be equal to 2 over 3. So this one disappears, and then put here 2 over 3, 2 over 3, then plus, we are adding a 6, so 3 times 6, that is 18, then plus 2, that will be 20, okay? So we shall have 20 over 3 of a, then this one is going to be equal to negative 9, then times 2 over 3. This one goes here 3 times, not so. So you have negative 6, then plus the 46, and then that one will give us a 40, not so. So this one will give us a 40 on the right side, and then our a then becomes, this one goes here 2 times, so 3 times 2, that's a 6. So a becomes a 6. So therefore, we conclude and say, is this a function in x? No, they didn't say it's f of x. So therefore, I'll get this one here, and I duplicate it. I said therefore this one here is equal to 4, then plus, then I take away this one here, and then I bring this part here, just like that. So where there is a, then I will put what? A 6, and then where there is b, I put a negative 5. So I can actually say minus here, then 5, and then this one here is a 6. So that is our final answer, as simple as that. Now part B, you see that it is coming from binomial expansions. They are saying hence obtain the expansion, this one in ascending powers of x up to and including the term in what? X squared. This one here, 12x squared plus 15, it's 55. 55x minus 2 out of 3x minus 2 into x plus 6. We have seen this one is equal to 4, okay? Then plus 6 out of this one, but I will write it as 6, then times 2, this negative 2 plus 3x, then to the power of negative 1, and then there is a minus 5, which we got as the value of b, then x plus 6, I'll write this as 6 plus x. Because remember, we are going to expand in ascending powers of x. You see that? So x has to be the second term, because using the binomial expansion, we have a plus b to the power of n, and then we have a, then power n, and then we have b power 0, then over 0 factorial. The rest will be like you are differentiating with respect to a. So you will say you will get n here, then a power n minus 1. The power a loses is picked up by b, and the power of b is the one that goes into the factorial. So again here, when you drop this one down, you will get n minus 1 multiplying with the n, then a, then power n minus 1 minus 1, that will be n minus 2, then b now here to the power of 2, then over 2 factorial, like that. So you can see that the first term is reducing in the powers. Do you see that? But the second term is increasing in the powers. Now, if you go with this one here, 3x being here, and then the minus 2, that means when you are putting in here, this x will be reducing in the powers. You see that? And then negative 2 will be increasing. Yet you're supposed to be expanding, and x is supposed to be increasing in the powers. Such series here, they are infinite, they never end. So that's why they tell you to expand up to a certain term, okay? Because if you're having negative 1, you keep on subtracting 1, it will become more and more negative. You never get a 0, right? Now let's begin with this one here, negative 2, then plus 3x, then to the power of negative 1. So we shall have negative 2. Please take it with its sign. If you leave the negative there, you will get wrong things, okay? And then the next one here is going to be, of course, the power is negative 1, then 3x here, power 0, out of 0 factorial. Then plus, drop the power, negative 1. Then this negative 2, its power is now a negative 2, then 3x, then to the power of 1, out of 1 factorial. And then drop this negative 2 also. You will get negative 1, then times this negative 2. Now, the negative 2 we are having here, its power changes to minus 3, and then this is 3x, then to the power of 2, out of 2 factorial. This one is continuing, but they told us to end here. Okay, simplified, this one will be 1 over 2, negative 1 over 2, okay? And then here, we have 1 over negative 2 squared. This one becomes a 4. Now times this negative 1 here, then there is a 3. So it is negative 3 out of 4, not so? So if we have negative 3 out of 4 here of x, and then next, this is 2. So it cancels with this 2 here. 2 factorial is a 2. And then we know that all the power of a negative is always a negative. So this one is going to be 1 over negative 2 power 3. Okay, this one is going to give us negative 1 over 8. Okay, I'm dealing with this. But then there is this 3 here squared, which is a 9. So we are going to have negative 9 out of what? 8. Okay, so that is what I'll write here. Negative 9 out of 8, then x squared. Just like that. Then we also come to this one here. We have 6, then plus x to the power of negative 1. And then this one is going to be 6. You power it with a negative 1, then x with a power 0, then 0 factorial. Drop the power. So we shall get negative 1. Then reduce it by 1, it becomes negative 2. And then here 1, then 1 factorial. And then drop this negative 2 here. You will get negative 1 times negative 2. Then we shall have 6 here, then to the power of negative 3, and then x here to the power of 2, then out of 2 factorial, and this one is continuing. Okay, now this one will be 1 over 6, okay? 1 out of 6. And then after that, what else do we have? Let's go to this one here, 1 over 6 squared, that is 36, so it will be 1 over 36 of x, okay? And then, how about this one here? Of course, this one will cancel with this. 6 cubed is 216. So I will have 1 over 216. and then x what? Squared. It goes like that. So that means this one here shall be, I'll just slide it down here, and I say 4, then plus 6, then times what we have gotten here. It's a negative a half minus 3 out of 4 of x, and then minus 9 over 8 of x squared. Okay, and then we also add on this other one here. It is minus 5, then into this one here, which is 1 over 6, then minus 1 over 36 of x, and then plus 1 over 216 of x squared. Then what I do, separate terms. So the constant term here is going to be 4. Okay, we have a 4 here, then here you'll get a negative 3, not so? Then here you get a negative 5 over 6. Negative 5 over 6. Then let's go to the terms in x. We have 6, then times this one here. So 6, then times negative 3 over 4. Okay, and then we have negative 5, then times this one here. Then we have, that one will be a positive, so I will just write plus 5, then out of 36, not so? That is for x. Then we also have for x squared 6, then times this one here. So we have 6, then times negative 9 over 8. And then we have negative 5 with this one here. So negative 5 out of 216. These ones here, x squared. Okay. Then after that, if I want, I can even put on plus. They are continuing. We are ignoring higher powers. So 4 minus 3 is giving us a 1. Then 1 minus 5 over 6, isn't that 1 over 6? That is 1 over 6. So that is what I will put here. And then inside here, what do we get? 6 into negative 3 out of 4. Then we add 5 out of 36. We get negative 157 over 36. Negative 157 out of 36 of x. Then how about here? 6 into negative 9 out of 8. Then minus 5 out of 216. We get negative 1463. 1463 out of 216 x squared, going like that. So that becomes our answer. Question 10 is coming from vectors with respect to the origin O. The points A, B, and C have position vectors given by these ones here. It is given that the length of AB and the length of BC are equal. Find the value of B. So we need to find AB and then BC. So AB is going to be equal to OB minus OA. Okay, so why is it like that? It is because if I have, let's say this is point A and then this is point B, then this is the origin. All of them come from this origin here. Okay, so like that. Now for me to get AB here, I'll say this one is equal to AO. You see that? AO, then plus OB. Now here I'm going into the opposite direction of what? Of OA. So this is the negative of OA, then plus the OB. So that's why I always say, like in algebra, we always say that you get the positive first and then the minus comes at the end. So that's why we say this is OB, then minus the OA. So you don't need to waste time. When you reach here, if it is AB and you have the position vectors of A and B, you just say the last one minus the first one. You get it? Okay, so what is our OB? It is B minus 2, then 3. Then our OA is 2, negative 1, negative 6. And this one is going to give us B minus 2, negative 2, then plus 1. We shall get a negative 1. And then 3 minus minus 6, that one adds up, so we get a 9. Then we go to BC. So what will be BC? BC is going to be then OC minus OB. So what is OC? OC is here, negative 4, then 5, then negative 2. Then we put off OB, which is B, negative 2, 3. And then here we shall have, what shall we have here? Negative 4, then minus B, and then 5 minus minus 2, that will add up to 7, and then minus 2 minus 3, that one will be minus 5. Okay, now they have said that the length of AB then is equal to the length of BC. So I'll have the square root of AB, which is B minus 2, then squared, plus negative 1 squared, and then plus 9 squared. Then this one is equal to the square root of negative 4 minus B squared, then plus 7 squared, then plus negative 5 squared. Now, we square both sides, the square roots will go, okay? Now, here, what do we have? Square the B, then 2 times B times minus 2, that will be minus 4B. And then this is 81 plus 1, isn't that 82? This is 82, but when you square this 2 here, I had forgotten, that one is going to be a positive 4. Okay, then we go to this side, square the negative 4, you get a positive 16, then 2 times negative 4 times negative B, that one I think will give us a positive what? 8B. And then square the B here, you'll get B squared, and then this one here is 49 plus 25. 49, 25, isn't that a 14? Take 1 here, 74. So we have a 74 here. Now, B squared, you can see that it is on both sides, so it disappears. Okay? Then, this one is 86, so we have 86 minus 4B. Then this one is going to be equal to 8B here. 16 added to this will give us a 90. So plus 90. Take this one this side. We shall have 8B, then plus the 4B. Then this is 86, then minus the 90. This will be a negative 4, and then this will be a 12B. Then B becomes negative 4 out of 12, which becomes negative what? A third. So B will be negative a third. As simple as that. Then part B, A, B, C, and D are vertices of a rhombus. Find the position vector of D. So I can have maybe this is my A, my B, then something like that. They are all equal in length. Okay, that's a rhombus. So we have A, we have, let's say, B, then C, then D. Okay, this one is parallel to this one here. So they want us to get the position vector of OD. Now, here, let me actually just extend this one to there. We can see that AB, okay, this vector AB has to be equal to vector DC, okay? This one is equal to this, or you can say this AD is equal to BC, whichever you want. Now, do we have our AB? Our AB is here, B minus 2, then minus 1, 9. B minus 2, minus 1, and then 9. DC is going to be equal to OC, okay, minus OD. So OC, let me just put OC minus what? OD. So our OC, in fact, let me take this one down here to be so systematic. Let me say this is AB, which is going to be equal to OC minus OD. Now make OD the subject, bring it this side, become a positive, then is equal to OC minus the AB. Not so? So what do we have as our OC? OC is here, -4, 5, -2. So -4, 5, -2, then minus our OB, AB is this one here. You see that? So that means we are going to have -4, then minus B. So B is a -1/3. We got it. Then plus the 2. Remember, this negative affects everything, okay? Then we have 5 minus -1. Of course, this one is going to become a what? A plus. And then -2 minus 9. So what is going to be our OD? From here, we can have -4, then plus 1/3, then plus 2. That one will give us -5/3. -5/3. This one is 6. This one is -11. I can leave it here just like this, or I can say OD in terms of I, J, and K will be -5/3 of I, then plus 6J, and then minus 11K. Even this one is okay. And then they're saying calculate angle ABC. Angle ABC. So here we're going to use the scalar product, okay? Using the scalar product. You are supposed to use AB. It is ABC. So when I come to this one, ABC, it is here. So you either open up or you close in. What do I mean? You can say A to B, then C to B. Okay, you are closing in. Or you say BC, then BA. Those will be the ones you have to use. So let me close in AB and then CB. Okay, now what is AB? AB, we have the vector. Okay, AB, the vector is which one here? It is this one here. So -1/3 minus 2, this one will be -6, then minus 1, that will be -7. It is -7/3. Then we have a -1 and 9. Then we also have BC. What did I say? It is CB. So CB is the negative of BC, not so? CB is the negative of BC. So what is our BC? I think we found it before. BC is here. So it is -4, then minus 1/3. So this one becomes a plus, right? So 3 times this, you'll get -12, then plus 1, that is -11. So we have -11/3, then 7, and then -5. So the negative of this one will turn this one to be a positive, then this one a minus, and then this one a positive. Clear? So that means when I go back this side, BC is going to be 11/3, -7, and then +5. Now I need to get their lengths. Okay, I need to get their lengths. So remember, we have to get AB. We dot it with the CB. We dot it with the CB. Then this one is equal to the modulus of AB, then times the modulus of CB, and then cosine of the angle in between, which is that angle is ABC. Okay, now let us get the length of AB here. This one is going to be negative 7 over 3 squared, then plus negative 1 squared, then plus 9 squared. So what do we have altogether here? Square root. Then we have negative 7 out of 3. Then we square that, then plus 1, then plus 81. That one is root of 787. Root of 787 out of 3. Now when we check here, they said that the length of AB is equal to the length of BC, which is the same as CB. Okay, so it is the same length. So when I come to this one here, I'll say that this AB here is the same as what? The length of CB. So CB, this one here, is equal to the length of AB. So I leave it there. Now we come to this one here. This one. Now the dot product is going to be 7 over 3. And then we have a negative 1. Then a 9. You dot it with CB, which is 11 over 3. Negative 7. Then 5. Then this one is equal to, here we have seen it is root of 7. 8, 7. Then out of the 3 here. Same thing here. Over 3 here. Then cos of the angle ABC that we are looking for. Okay. Then these ones multiplied, we shall get negative 77 over 9. Then here plus 7. And then here, that is a 45. Then this one times this, of course the square root disappears, so we shall have 787, then out of 9, okay? These 3 is multiplied. Cos of angle ABC. So what is this one here? Negative 77 out of 9, then plus 7 plus 45. That one is 391 over 9. 391 out of 9. Then we shall say times 9 out of 787, because I want to make angle ABC the subject. Then will be equal to cos of angle ABC. So meaning angle ABC then shall be equal to the arc cos of the whole of this. So arc cos of 391 out of 787, because this 9 disappears, not so? Alright, so what will be our answer here? The calculator can be in degrees or in radians. So if I use degrees, it will be the arc cos of 391, then divide by 787. And that one is 60.2. 60.2 degrees. That is to 1 decimal place. Or if it is in radians, what we get? I'll just come here and then I change the what? The mode to radians. Shift, then mode. Radian is 4. Then press equals again. That is 1.05. 1.05 what? Radians. So that is that. You write one answer, either in degrees or in what? In radians. Don't write like this in the exam, okay? Don't waste that time. And the last question of this paper is coming from differential equations. The variables x and y satisfy the differential equation. This one here, it is given that y is equal to 0 when x is equal to 0. Solve the differential equation and find the value of y when x is equal to 2. Now, here, we need to separate variables, okay? Separating variables. And I've already said that here we use majorly the operations of multiplication and division. So take x this side, bring the y here. So here I will have 1 over e power 3y, then dy. Then here we are having x minus 2, okay? When you cross multiply here, the dx will come there. You see that? So we will get dx here. Then after, we shall divide through by this x squared, then plus what? The 3. Now integrating. You need to integrate both sides, because to undo derivatives, we integrate, not so. So we solve differential equations using what? Integration. So this is e to the power of minus 3y dy, which is equal to the integral of, I can split, by the way, this numerator here. I can have x out of x squared plus 3. You see that? Then I will also have minus 2. So the integral of 2, then out of this x squared plus 3 dx. Now, we know that when you integrate e to the power of a function, okay, then this one is going to be get the derivative of that function. You divide it in this exponential function. If it is differentiation, we multiply through, okay? So the operation that undoes multiplication is division. And here we are dealing with integration, which is the reverse of what? Differentiation. That's why we divide. Okay, now here, when you differentiate this one, but before we come to that, we are going to use this integration here. If you have a constant here, and then you have something plus x squared here, that is an arctan, okay? So when you integrate 1 out of, then we have x squared plus a squared. It is given even in the list of formulae, that is 1 over a, then the arctan of x out of what? Of a. So you just need to transform this one here. This one here is going to be root of 3 here, okay? So 3 is the same as root of 3 what? Squared. That means our a here will be that root of 3. You see that? Then we also have, what else do we have? When we differentiate here, if you see that here you have x squared in here, and then up here there is an x. So we can manipulate this one, and we say that if we differentiate the denominator, okay, we can get the numerator, but this is 2x, but we have to do something on it. So what do we do to this 2x to get the x? We divide it by 2, right? Now, that operation you do onto this derivative is what is going to become the coefficient of the natural log of your denominator. You see that? Okay, so this implies, now let's come to this one here. When you integrate, you will get e to the power of negative 3y, divide by, when you differentiate this with respect to y, you get a negative 3. I'm applying this one here, okay? Then we go to this side. Here, this is the same as saying you're integrating. I'm now writing this one in terms of the derivative, okay? So it is going to be a half, then times the derivative of the denominator. You see that? The derivative of this denominator is 2x. Now, when you multiply it by a half, you will get the x here. We are together? Then we divide by this x squared plus 3, then with respect to x, and then minus, put the 2 here, then we are integrating 1 out of, this is x squared, then plus root of 3, and then what? Squared. Okay, then another thing we should know is that when we integrate, and we see that what we are having in the numerator is the exact derivative of the denominator, okay, then this one becomes natural log of the denominator, okay? Yeah, so this is very important, and these are the things that we are going to use. So let me take this one up here. But in the exam, you don't need to write all of this. What we need, now this one here becomes negative a third of e to the power of negative 3y, which is equal to, this one is going to be a half, then the we see that when I pull the half here, then I will be having the exact derivative of what is down. You get it? So in the exam, we just expect you to write this one here, a half, natural log of x squared plus 3, okay? Don't write any of this like in the exam. We don't need it. Me, I was just showing you, okay, where they come from. Then here, we shall have minus 2, then times our a here is the root of 3, okay? If you compare with this one, it is going to be the root of 3. So we shall have 1 over root of 3, then the arctan of x, then out of root of what? Of 3. You get it? Then plus c. Now we need to find that arbitrary constant. Now in differential equations, when we integrate up to here and then we put this arbitrary constant of integration, this is what we call the general solution. Now using the values given here, we can get the value of c, and there, after getting c, we get what we call the particular solution. You see that? Now we put this arbitrary constant because we don't know the constant which disappeared when they differentiated. You get that? Okay, now let's put x is equal to 0 and then y is equal to 0. So what shall we have here? You have negative a third, then e power 0, which is a 1. Then this is a half, then the natural log of this one is going to be 0 squared. This one will be a 3, not so? Is 0, then plus the 3 here. Then how about here? We shall have negative 2 out of root of 3. Then, of course, arctan of 0 is a 0. So that means I'll take this one out. And then we have plus c. That means c is going to be, take this one this side, is going to be negative a third, then minus a half, natural log of 3. So meaning our particular solution is going to be, I'm going to get the whole of this as it is, then I just duplicate it here, and then where there is c, I'm just going to put this value that I've gotten here, this one here. So that becomes our general solution. So that is our general solution here. But they said find the value of y when x is equal to what? To 2. So when x is equal to 2, what will be y? So negative a third, then e power negative 3y, then is equal to, this will be 4 plus 3, that will be a 7, so a half, natural log of 7, then minus, this will be 2 over root of 3, then the arctan of 2 over root of 3, not so? Then what else? Minus a third, then minus a half, natural log of 3. So there is a lot to do here. Then we are going to have, I can write this as, okay, multiply all through by 3. In fact, negative 3, so that this one becomes a positive. Then this one will be 1 over e power 3y, not so? This e power negative 3y is 1 over 3, 1 over e power 3y. Then, remember multiplying all through by negative, so we shall have negative 3 over 2, then natural log of 7, then this one becomes a plus 2, this one times this, don't you get 6? So positive 6 over root of 3, then the arctan of 2 out of root of 3, and then this will be a positive 1, negative a third times this. Okay, that's a positive 1. Then this will be positive 3 over 2. Natural log of what? 3. Now, we are going to cross multiply. Okay, so the whole of this will come down here, and then e power 3 will go up there. You get that? So we shall have 1 out of, I'll just get the whole of this and I shift it down here. You see? So we shall have this one here, then is equal to e power 3y. Then we introduce natural logs on both sides to undo this one. The exponential, we use natural log. So natural log of whatever we have here. You see that? Natural log of this one here, then will be equal to the natural log of e to the power of 3y. Now this one will come down here. You see that? Then you have 3y, then natural log of e. So 3y natural log of e, and then after we divide all through by 3. So this therefore implies that y is going to be a third, okay? A third, and then the whole of this one here. So let me just shift this. and then I just bring it down here. Then I put this one in the calculator and I write my answer to 3 significant figures, right? Is that what they said? Okay, they never tell us, but they just said find the value of y, so you write it to 3 significant figures. Okay, let's go. A third of natural log. Now we have a 1, then down here you have negative 1.5, then natural log of 7, then there is 6 out of root of 3, then the arctan of 2 out of root of 3, okay, then plus 1, then plus 1.5 natural log of 3, okay. And then from there we can close the brackets here, then we press equals. Now your calculator, by the way, has to be in radians because there is an arctan, okay, and this one gives us negative 0.331, negative 0.331, that is to 3 significant figures. That is that. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.